Hey guys, hope you're doing well. We're going to start Unit 12 today on limits, and today's lesson in particular, 12.1, we're going to talk about function symmetry. And the first type of function symmetry we're going to talk about is even. So what makes a function even? Well, a function is even if it has symmetry with respect to the y-axis. All right, so a simple function that we can talk about that we know has symmetry with respect to the y-axis is f of x equals the absolute value of x. And I'm sure you guys remember what this looks like. It's just our v. And I want to talk about a few points on each side of this. So let's talk about 1, 1, 2, 2, and we'll make up a generic coordinate x, y. So on this side here, we've got negative 1, 1. We've got negative 2, 2, and we've got negative x, y. Now visually, it's kind of easy to see, yeah, this definitely has symmetry with respect to the y-axis, but we don't want to have to graph every single one of these. So what we want to do is we want to come up with a rule or an algebraic method for determining whether a function is odd or even or neither. So let's take one of our points, f of 2, okay? We can see from the graph what it's going to be, but let's just plug it into our function. Absolute value of 2, well, that equals 2. Then let's take the opposite, f of negative 2. Okay, so that's going to be the absolute value of negative 2. Well, hey, that's also 2. So what do we notice in this case? We notice that those two are equal. So it seems, though, if you plug in a number and its opposite and they're equal, then it makes a function even. Now, this works for 2. I don't really want to do this an infinite number of times to prove it, so what do we do to prove it? Well, we have to plug in variables. So I need to evaluate f of x and f of negative x. Okay, well, again, this is pretty simple. You plug in an x, the absolute value of x, guess what? You get x. You plug in a negative x, the absolute value of negative x is also x. So now those two results are equal. Therefore, my function is even. So to prove a function is even, what you need to show is that f of x equals f of negative x. And that's the big test for whether a function is even. Okay, well, let's talk about odd. All right, so an odd function is a function that has symmetry with respect to the origin. Now, if you remember back from geometry, that's simply a rotation of 180 degrees about the origin. So if you can turn this upside down, it's the same image, then it's odd. Okay, so here's an easy function to deal with. F of x equals x. Well, it's just a linear function. It looks like that, roughly. So again, a couple points on here. 1, 1, 2, 2, x, y. Okay, down here we'd have negative 1, negative 1, negative 2, negative 2, negative x, negative y. So what's going to determine here algebraically whether a function is odd? Well, let's plug in 2, and let's plug in negative 2. Well, again, this is pretty easy because look at it. You just get out what you put in. So this is going to give me a 2, and that's going to give me a negative 2. Well, clearly those are not equal, but they are kind of related because those are what we call opposites. So it appears that if I plug in a number and its opposite and I get opposites, maybe that makes the function odd. Well, again, I don't want to do this an infinite number of times for every single number, so what I have to do is prove it with a variable, f of x and f of negative x. Okay, well, again, simple, right? Because I just get out what I put in. So f of x is just going to be x, f of negative x is going to be negative x. So since those are opposites, that makes my function odd. So what I need to prove here is f of x equals the opposite or negative f of negative x. So if this ends up being the case, then my function is odd. If those two are exactly equal, then it's even, and if it's neither one, then obviously we would say neither. Okay, let's try a couple examples here. Determine if the following functions are odd, even, or neither. Well, I'm going to give you guys a little bit It's not really a shortcut, but you can anticipate maybe what the answer is going to be. If you notice those two exponents, they're both even. If they're both even, does that make the function even? Well, if you think it is going to be even, remember we need to prove it. You could plug in a number if you want. Maybe I'll do that right now real quick. Plug in a 2, and then plug in a -2. Let's see what we get. So if I plug in a 2 here, I'm going to get 2 to the 4th minus 2 times 2 squared. All right, if I throw that into the calculator quickly or do it in my head, let's see, we get 8. This is going to be, now you got to be careful with your parentheses, -2 to the 4th, so that's also going to give me a positive 16, minus 2 times -2 squared, which is also going to give me a positive 4. Well, guess what? That also gets me an 8. So I'm guessing right now those are equal, therefore my function is going to be even. But again, this isn't enough to prove it. You've just shown that it works for 2 and -2. So to prove it, we need to use x and -x. Okay, well, if I plug in an x, well, that's simple. You just rewrite what you have in the original. But again, you got to be careful here, and you've got to show this work. F of -x is going to be parentheses, -x to the 4th minus 2 times parentheses, -x squared. Well, remember our property of exponents. If I have a negative number or negative term, and I take it to an even exponent, that's going to make it positive. So this ends up being positive x to the 4th, and this ends up being positive x squared. So what I get here is x to the 4th minus 2x squared. So now I compare these two. Yes, those are equal. Therefore, my function is even. Now, what's the required work here for this problem? This. So that kind of brings this into play. If you can anticipate in the beginning that your function is going to be even, you know you need to prove it, and you must prove using variables. All right, so keep that in mind. All right, so let's take a look here. Again, let's anticipate 3, and really that's a 1, remember. So it looks like these are both odd. Does that mean my function is going to be odd? Well, if I anticipate that my function is going to be odd, I'm going to have to prove it. So I'm going to go right to my variables. Okay, well, f of x is simple. F of x is, you're just going to rewrite this. That part's easy. So that's going to be x cubed plus x. Now, f of -x, remember, use your parentheses. Parentheses, -x cubed plus -x. Well, now remember, when we take a negative to an odd exponent, it's going to stay negative. So this is going to give me -x cubed. And then obviously this is going to be minus x. So what we need to do now is we need to compare these two. If there's multiple terms, each one's got to be the opposite, and that is true in this case. Those are opposites. Therefore, this function is odd. Now, if you had to explain this a little bit further, I would say something like odd because f of x equals the opposite of f of -x. And that's probably a good explanation to get used to writing down to determine whether a function is even or odd or neither. Okay, let's keep going. So this is important right here, this note. You may disprove numerically, because to disprove, you just have to show it doesn't work one time. So that's why you can just throw in a 2 and a -2, and if you get neither, great. But you have to prove algebraically. So that means you must be using x. All right, so let's try this one, see if we can anticipate an answer. Now, this is kind of interesting. We see x cubed, you think, oh, that's odd. But this also has an x term. That's x to the 0. So now I've got an odd exponent in the 3 and even, I guess, and 0. So I'm guessing that this is going to be neither. Now remember, this is a guess. And that's not enough just to say neither. You have to show it. So what I'm going to do now is I'm going to say, if I think it's going to be neither, I'm just going to plug in a 2, and I'm going to plug in a -2. And if those two are not equal and they're not opposites, then it's neither. So let's see, what do we have here? 2 cubed plus 2. That's going to be 8 plus 2. That's going to be 10. This is going to be negative 2 cubed plus 2. So remember, negative 2 cubed is negative 8. Negative 8 plus 2 is negative 6. So they're not equal. They're not opposites. So this is going to be neither. Oops. Neither. Okay, couple more. All right, now this one's kind of interesting. F of x equals 12. You're thinking to yourself, well, wait a minute, I don't see any exponents here. I don't see a variable. Well, remember, this is kind of easy to do because, yeah, if f of x equals 12, f of anything equals 12. You're not plugging in, so f of negative x also equals 12. So we are using variables. My results are equal, so I'm going to say equal, therefore my function is even. And further explanation, I would say even because f of x equals f of negative x. So when you plug in an x and you plug in a negative x and you get the same thing, that means the functions are even. All right, now we can get a little bit more interesting. So again, let's anticipate. That's an even exponent. That's not exponent. Remember, that's a 1. So again, I'm guessing neither. And this really helps to anticipate. So if I think it's going to be neither, I'm just going to throw in a 2 and a negative 2. So that's going to be 2 squared over 2 plus 2. And then I have to plug in a negative 2. Don't forget your parentheses. Negative 2 squared over negative 2 plus 2. Okay, well, 2 squared is 4. 2 plus 2 is 4. This ends up being 4 over 4, which is 1. Negative 2 squared, also 4, but check this out. I get a term that's undefined. So basically, these are not equal. They're not opposites. So my answer is neither. It's not odd. It's not even. You just say neither. You can disprove with a number, but you must prove with a variable. That's crucial that you remember that. Okay, let's just do one more. All right, final one. F of x equals x squared minus 2 over x. And once again, we can kind of anticipate because that is a 1. My exponents are different. So I'm guessing it's going to be neither. It's not enough just to write down neither. You have to show. So you can disprove with variables. You can disprove with numbers. I'm going to use numbers. I think that's a little bit easier. F of 2, 2 squared minus 2 over 2. F of negative 2, negative 2 squared minus 2 over negative 2. Okay, so let's see what we get up here. I get 2 squared is 4. 4 minus 2 is 2. 2 divided by 2 is 1. Negative 2 squared is 4. 4 minus 2 is 2 over negative 2. Oh, wait a minute. So right now, I've got two numbers that are opposites. So to me, that would indicate that it's odd. Well, it's not enough for me now just to say, oh, it's odd because these are opposites. Remember, I've just shown that it works for 2 and negative 2. You'd have to show it works for every single number. So now I have to go to prove mode. And I have to say, well, I'm going to have to prove this. I'm going to have to go to f of x and f of negative x. Well, again, f of x is easy. You just copy down the original. F of negative x, you have to plug in a negative x in every location. Now, this is a little bit tricky, and fractions get confusing. So negative x squared is positive. So what I end up getting here is x squared minus 2 over negative x. And as you compare these two fractions, remember what would make one fraction the opposite of another. It's not negating every single term in the fraction. It's either negating the numerator from one to the other or negating the denominator. So if you notice here, our denominators are opposites while our numerators are the same. So these are indeed opposites. Therefore, my function is odd. Okay, so I would say again here, it's odd because f of x equals the opposite of f of negative x. okay? And everything that we have here in green would be the required work. So what some students like to do is they don't like to anticipate. They just like to do this process for every single problem. And if they get opposites, it's odd. If they get equals, it's even. If it's neither, it's neither. That's great. You can do that. If you can anticipate ahead of time that it's going to be neither, you could disprove with the numbers. So it's not wrong if you do both methods. If we had more time, I might do a few more examples where I do both methods. But basically what you need to be able to do algebraically is determine if a function is even or odd or neither. Okay, so that concludes the first lesson. It's actually the first half of the lesson for Unit 12. Please do the associated homework problem or homework assignment for this lesson, and do not hesitate to reach out if you have any questions whatsoever.